So a mixture of three picomoles, each of human serum albumin, HSA, and immunoglobulin G, which is IgG, was ionized and analyzed. The MALDI-TOF mass spectrum is shown below, and that's this one right here. Estimate the molecular weight of each protein. Okay, so MS is going to be fragments of these proteins. Okay? And we want to round these to the nearest one. And so what we have to do is we have to then assemble these fragments, stitch them together. Remember that these are always going to be MZ, meaning mass over charge. Okay? Okay, so for example, if we see any that are charged 2+, then that would be, that means this number is divided by 2, right? So we would have to multiply it by 2 to get the mass out of it. Does that make sense? Okay. Typically, one of these up here is going to be something that's along the lines of a charged full complex with maybe a hydrogen added to it. If we get lucky, we would have something with just a hydrogen. So it would be, we subtract off 1 when we get it. However, we might have to look at if it was generated by a oligomer, then your values for your mass to charge ratios are going to have to be divided by the number of components in that oligomer. So like if they bind together, okay? If they have multiples of the same. For example, I think up here it has like 2. Yeah, see that? Mm-hmm. It's 2 of these bound together. Okay? Okay. Oh. Yeah. Couldn't see that. Yeah, that would be an easy place to take this off, right? Yeah. So you would go there, and that's your HSA mass there. And so congratulations. Bam. You got it. Is that making sense? Yeah. Yeah, I mean, not all of them will always be so straightforward, but yeah. There is a pretty good shot that you're going to have one that's just one of those, right? Non-oligomer. Though you can do it with the oligomers. I mean, it's not a problem. Like if you look at this one up here, 3 times, right? So divide by 3.
You would divide that after you multiply?
Divide. Because it's 3 of them, so you have to divide it by 3 to get 1. Yep, and then you can do the IgG, I believe you need to do. Don't forget to round it, though. So it's 0.9. Yeah, you got to round it up. Did that clarify that?
If it was on the, if it was one of the IgA plus a multiple of the hydrogen, would you multiply it in?
Yeah, so you're going to not multiply. What you'll see is that, okay, so let's go up here. Oh, okay, I'm sorry. Yes, you got it. Yeah. You're talking about these ones that are 2H+. Yeah, so this is actually, it's kind of the wrong way to represent this, by the way. Whatever. So yeah, it has 2+ charge, so you're going to have to multiply that by 2 because it's being divided by it too. Yeah. Yeah. I have no idea why they thought they had to do plus 2h plus and not just 2 plus next to it. You know, superscript. Yeah. Yeah, it's really funny. Oh, that's a nice job. I forgot they had references even in the questions. Yeah. That's actually taken from the publication. It's real world data. That's why everything's fractions. And there's like one whole number. See that? That's how you know it's real world. Because everything's fucked up looking. No consistency.